Thank you. We have much to talk about and not so much time, so let's get started with don't let just Node.js take the blame. I'm Daniel Kahn. I'm from Austria. We are known for Mozart, maybe, Red Bull, and Californian governors. This is how we look like on a regular Sunday, just to give you an impression. When I started in the industry, websites looked like that. This was the big time of GeoCities. And when I founded my first company, I had to go to the bank to get a loan, to buy a server, to set it up at home, and then to bring it to a server center to kind of put it into the rack, and then bam, it was here. Now we are talking about serverless and stuff, so times really have changed in the last 17 years. I'm now working for Dynatrace. I'm Node.js technology lead there, so I'm kind of sitting between customers, product management, marketing, development, and kind of, what is there? Oh, there is this. This is weird. Hey! That's weird. Now I don't see my next slide, but anyways, it will work. Node technology lead, Dynatrace, sitting between marketing and stuff. Not always easy, but also very interesting because we are working with quite a lot of big enterprises, and we see Node.js a lot. This is what we actually do. So this is performance monitoring. You get the drill, basically. We see Node.js mostly as what company outlaws use to finally introduce change. So some people go on some quest. They want to change things. They're brave, right? In reality, they look like that. For instance, that's Alex Balázs of Intuit, who built the whole TurboTax around Node.js in a thing he called Pirate Ship. So this was they worked after hours to just do something new, change things, get rid of legacy stuff. Trevor Livingston, at this time at PayPal, he's here. So PayPal found out that it takes them, I think, 6 months to change some text on the landing page of PayPal. And this was way too long, and they tried to find ways to make it quicker. So they used Node.js as templating or just rendering thing or prototyping thing at the start, and then kind of everything changed around them. Or Aaron Hammer, at this time at Walmart, now at Nearform. He created the Happy framework, who transformed Walmart around Node.js. And if we look at how Node.js is actually used, it's mostly like that. So we have Node, first of all, we need something new, some HTML5 application, something like that, or a mobile application. And then we have to find a way to get this old enterprisey stuff kind of to talk to these modern devices and to do it also quickly, serve many clients. And this is where Node.js comes into play because of its asynchronous nature, etc. You know about that. The problem comes when some things start to go wrong. So maybe this or the Tomcat fails, some mainframe or a database, whatever. In any case, even if it's within Node.js or is not within Node.js, Node.js may be the first point where things start to fail, because this is the new thing and there's something goes wrong. And I think we need to do something against that, because otherwise it will be like that. So all those people say, okay, oh my God, this hipsters now broke everything. And you're this guy then, trying to fix things in production, not knowing what's going on. So I think we need some kind of proactive defense, right? After all, Node.js is a C++ program controlled by V8 JavaScript, right? So it's really like that. JavaScript is a string. It gets stitched into the V8 engine, and the V8 engine compiles it down to really machinery code, not byte code, runs it, takes care of all those object allocations, deallocations, and everything. And every time a program is running, I think it's kind of, has two things or two states. Something going on a CPU and something stored in memory, right? And these are the things we should look into first when we look at problems in Node.js. So let's hunt some memory leaks. So the Node memory is organized very much like every kind of platform like Java. So we have a code segment, a stack, and a heap, and there we will store all those dynamic structures like objects. And then we also have this used heap that is so we allocate heap, and the used heap is that amount of the heap that is actually used then. And we can easily query Node.js for that, and just call process memory usage, and you get the resident set size, the heap total, and the heap used. And every time you can call something and get something out of it, it's tempting to just write it out into a CSV file and see what Excel can do with that, and that is what comes out then. So you see this resident set, the red line is the heap, and then you have this very volatile line, which is obviously because of garbage collection. That's an Austrian garbage collector. Sometimes things go wrong when it comes to garbage collection. To understand that, we have to visit my hometown, it's Linz. That's the house I'm living in. The house was built 1600 something, by the way. And there in the backyard, there's this door and there's this room, you know these rooms. And there is this stuff laying around since I'm living there. And the sign says, bitte nicht hier abstellen und gleich selbst entsorgen, which means don't put it there. Please put it away, we won't do that for you. If this happens in your code, it will look like that. That's a memory leak. And that's the garbage collector. So how can we build a memory leak? I looked a little bit around about how to do it. The easiest way is store the IP address of every visiting user in a global array somewhere, but that would be way too easy. There are, I would say, more elaborate ways to do that, and I found an example at the Meteor website, and I tried it and it works, or does not work, as you. So this is express route that is called, it's called leak, and it then calls replace thing, which is a function that has a certain kind of structuring in there. And I really encourage you, I will share that later on Twitter to look at that closer into the code. It's basically some references pointing to each other, but actually none of those functions in this whole function are called. Unused is not called, some method is never called, so you don't do anything. So you would think, what should go wrong? I don't do anything. But what is actually the case, and I've created a little bit of a drawing around that, you have this root namespace and you have the thing object. And the thing object is hooked to the root namespace. The thing contains a long string and some method that is never called. Then you have another method inside this object. It's called, inside this function, it's called unused. And it references, it references the thing again over original thing. And as we know, every time we create a function, it kind of has a closure context because a function has to know all the variables kind of floating around above it. So it really has to know what is there. So it has to have a closure context to unused, which again has a reference to the thing over original thing. And this is, at this point, maybe it's fixed in 6 already now, but this lets the V8 engine actually fail kind of deconstructing this whole structure, this whole path to find out, because the memory, the heap is actually a graph. And deconstructing the graph means, or finding out which object is never used, means finding objects that have no incoming path anymore. And with such a structure, this fails. And this is really the end result you get with exactly this example. So the heap grows continuously until it reaches its boundaries, and you have your memory leaks. So how can we look into that? How can we fix that? Node is based on V8. V8 has APIs for profiling. There are libraries you can use to export those profiling functions to the Node.js JavaScript userland. And V8 Profile is one of them. And I used that and used this, wrote a little script that just takes heap dumps continuously, and then did a simple comparison between two dumps, because then you see, oh, which objects are actually growing here, right? And by doing so, it was obvious, really obvious to find this kind of problem, because really this long string of asterisks I've created there really was piling up the memory. And I saw it on the delta between two heap dumps that this is constantly growing. And this is how you fix memory leaks. What you see here is Chrome Developer Tools. So you can use V8 Profiler and really feed what you have into Chrome Developer Tools, and it will work out of the box, which is great. So we have fixed memory problems. This is how you do it. There is no other way to do it, actually. So let's hunt some CPU problems. And let's explain the Node.js event loop. No, we won't. That was Bert Belder at Node Interactive Amsterdam. He wrote a lot of libuv, and he showed all the wrong drawings on the web about the event loop, and I just won't do that again now. Look it up, look at this video. When you want to understand the Node event loop, he should explain it. It's way better. Just a little thing. So every time you call something asynchronous, it goes into this whole libuv machinery, and it runs asynchronously, which is good. And then it comes back with the callback. And everything is fine until someone decides to calculate Fibonacci inside the callback. Because Node.js runs on a single thread. If you block this single thread, everything will be blocked, not in like maybe in PHP where you just have blocked this one thread. No, everything, no new request will be processed. That's a problem. Again, you can use V8 Profiler, and I used that to create CPU profiles. And I compared a CPU profile taken from, so what's on the CPU at a given time? That's what a CPU profile gives you. And I compared running an Express app in development mode and in production mode. And you see it, and you don't have, that's no rocket science. You really see very clearly that there is a lot more going on here. And if you hover, that's D3, and you can hover over the elements then, and you see that all those little segments are purely template compiling of Jade, the template engine I was used, PUC, it's now called. The neat thing about that was that if you don't define node env, it will actually default to development. So it's kind of not really transparent what Express does with this setting. And so running something with no node env defined is kind of cause really performance problems. So this app, the development mode is 2/3 slower than the production mode. So that's a way to find those problems. There was this Node.js Inflamed thing by Netflix where they had a problem. They had routing tables of Express kind of blowing up, and we're looking for a way to kind of debug this, or actually we're looking for a reason why the whole Netflix, all those routes were becoming so slow actually. And they had to restart their servers all the time, so something was wrong. And then they found out that this was because of some blown up routing tables. The theory behind that was that they thought that this Express routing table was a map, so on the left side you have the route, and on the right side you have the function, and if there are duplicates, the one route overrides the other. But actually it's just an array, and so they were filling up the routing table with that. And then you have a classical O of n case where the longer the routing table gets, the more complicated it gets. And I used again a CPU profile and this flame sunburst chart to find out what's really going on. And here, this segment you see here. So I've rebuilt this problem actually and created a very long routing table. And this whole segment here is finding the route. So you can really, using this technique, you can really solve real-world problems. There are tools for that. You can use. There's Node Monitor, there's NSolid that provides you a lot around Node.js, but the Node.js people are here, they will tell you a little bit about that. There's Upbeat, also a great solution. There's Trace by Rising Stack, and also Dynatrace. So there are a lot of tools that give you metrics around Node.js. But what if Node.js is not the root cause of all the problems, right? So let's go back a little bit in time. So in the 80s, everything was easy, right? That we had those mainframes, and when something was going wrong, you really knew to whom to talk to. And it got a little bit more complex with Java then, and then we had some websites that didn't really had a kind of effect here. Then we had all those SharePoint applications that were already talking with the backend, so the complexity was constantly rising. And now we are here. We have third-party libraries. We are kind of including some modules, Node.js in between, Angular everywhere. And the number of stakeholders kind of exponentially grow, because now who do you call when something goes wrong? And the problem is that those boundaries between those tiers are also boundaries between generations in some ways, different programming paradigms, different ways of thinking. And it's really hard to get all of those people together. And that is where monitoring comes into place. I want to show you a problem that really does not have really something to do with Node.js by itself, but surfaces in Node.js. It's called back pressure. I hope there are no car lovers here. I have to show you something. It's a little bit. And that's back pressure. More schematically, this means you have a Node application that can do 1,000 requests per second, and then you have your legacy backend that can do 10 requests per second. What will happen then, at some point, is that all those requests pile up in the Node.js event loop, and Node.js will start to error out. But is it really a Node problem? Most probably not. So we need some kind of border protection. I had a picture of Trump in here before for other talks, but now I've seen the people out there with those, and I'm not sure if I can do that anymore. So how to protect yourself? This is a little scriptlet. It just shows a way to create your own little monitoring solution. You call out to some backend, and then you time basically this callback and see how long it takes. And you log out errors, you log out everything, and you write your own little monitoring solution within your application, new code to maintain actually. And it's fine to use that and use a dedicated monitoring solution for every tier you're using, because they're always better, talking about node source, talking about Upbeat. But we should always see the big picture. I like this saying, we who could mirror stones must always be envisioning cathedrals. So when you are on the node tier, you should still consider that you're working maybe on a big solution and really see everything. And this is where transactional tracing comes into place. And this is where you should really listen to Thomas Watson tomorrow, because he will talk about how to instrument node applications and why this is really not so easy. We do this as well. We do this for many technologies, so to follow really every transaction through an application stack. And this is what you get in the end. And that's not just Node.js, that's everything. And that is where kind of the big picture starts. You see really what's going on in your application stack. You see how those tiers, those APIs are communicating with each other. Does some Node application or microservice maybe talk to the database directly, although it should talk maybe over an API. You get the point, right? So, or what is wrong with our microservices? So this is really, we call it Death Star, and that's really a pattern of a large infrastructure based on microservices. Really find the problem here. And this is where kind of monitoring tools come into place to kind of deconstruct this problem for you. This is also, the mushroom cloud is also when the problem gets bigger. And what you want to have in the end is one single alert about what really happened, right? And really finding out what's the root cause. Is it Node, or maybe is it the DB2 somewhere down the stack? Here's my summary. Use dedicated monitoring tools for debugging and tracing, and take it seriously. And you can use what's built into Node to actually do that. And you can build in switches into your Node application to switch on monitoring, for instance. So you can do this on your own. And then consider using tracing tools that trace through all your tiers to make sure that you're not the person to blame when something down the stack goes wrong and the exception happens to be thrown in Node.js. That's it. Thank you.